All right, think back with me for a second to your first algebra class. Remember x and y? They were just everywhere, right? Variables are the absolute bedrock of how we're all taught to think about math. But what if, and this is a big what if they're not actually essential? What if we could just get rid of them completely?
I mean, can you even imagine a world of math without x or y? What if you could build one of the most fundamental branches of math, set theory, without ever using a single variable? It sounds totally nuts, right? Kind of like trying to write a novel without using the letter E. But is it really impossible? Well, the answer, and this is what's so cool, is a resounding yes. It's not just possible, it's already been done. So today, we're diving into this pretty radical story, how you can build the entire world of sets with absolutely no variables at all. Okay, so what are we really talking about here? This thing is a full-blown alternative way to build set theory, right from square one. And you got to understand, this isn't just some clever little thought experiment. No, it's a totally rigorous system that proves that variables, as we know them, are actually optional.
Now, an idea this huge, this revolutionary, it doesn't just pop into existence, right? It takes some seriously brilliant people who are willing to look at the very foundation of their field and ask, why? So let's get to know the masterminds behind this whole thing. The two people behind this were the absolute legend, logician Alfred Tarski, and his collaborator, the mathematician Stephen Givant. I mean, think about it. Together, these two took on a concept that nobody had really questioned for generations and came up with a completely fresh way of looking at sets. And you know, they weren't exactly subtle about it either. The title of their huge, groundbreaking work just lays it all out there. A formalization of set theory without variables. Plain and simple. This single book laid out the entire system, proving it wasn't just a theory, and it really set the stage for everything that followed.
All right, so I know what you're probably thinking right now. How in the world do you do math, let alone something as complex as set theory, without variables? It feels like the whole thing should just fall apart. So let's get into the nuts and bolts of how this super elegant system actually pulls it off. The secret sauce here isn't magic. It's something called relation algebra. Okay, think of it like this. Instead of using X to stand for, say, any student, you create an operator for the relationship itself, like the concept of is a student of. See the shift? You're not focused on the things anymore, but on the connections between them. They didn't get rid of the logic, they just changed the language, shifting it from nouns to verbs, from static objects to dynamic actions.
So, how does this all come together? Well, the whole system is built on these relation algebras, and this is the key part, it relies entirely on equations. That's it, nothing else. It's what's called a fully equational system. And the real beauty here is just how clean it is. Instead of these long, messy, logical statements full of variables, you end up with a really short, simple set of rules. And that tidiness, it's not just for show. It turns out to be a massive advantage when you bring computers into the picture.
Okay, this is all really fascinating abstract stuff, for sure. But I get it. You might be asking, so what? Why should I care about this today? And that's a fair question. Turns out, this pretty abstract idea from decades back has found an incredibly powerful and very modern use case.
So here's how we get from this abstract theory to the real world. Remember that clean equation-only system we just talked about? Well, it's pretty much perfect for computers. There's no ambiguity, nothing for a machine to get confused by. This makes it ideal for just mechanically crunching through logic, which is exactly what computers are amazing at. And this clear, direct path is exactly what has led to some huge breakthroughs in a super cool field, automated theorem provers.
So, if you take one thing away, it should be this. Tarski and Givant's work gave us a powerful new toolkit to help computers think logically. It lets them systematically check and even discover mathematical proofs all by themselves. This whole field is called automated theorem proving, and it's a straight line from this wild, abstract idea all the way to cutting-edge computer science.
And that really leaves us with one last big thought, doesn't it? Tarski and Givant looked at the variable, something everybody just took for granted, and they had the nerve to ask, hey, is there another way to do this? And it just makes you wonder, what other fundamental ideas, whether it's in math or science or really anywhere, are just sitting there, waiting for someone to come along and completely reimagine them?